And we're live from downtown Mill Bay. I hope so. We added some new terms, homozygous and heterozygous. Homo meaning the alleles are the same. Heterozygous meaning that they're different. We went through a regular Punnett square. We did a problem with a regular Punnett square with unicorns and dicorns. We did the ratios of those unicorns and dicorns, and they put numbers in them. And then we introduced a new trait called incomplete dominance. And that is, we still use uppercase and lowercase letters, so if you just got the package, we actually changed some of the notes. Some textbooks actually use 2 uppercase letters. Turns out, not most of them. And that is confusing when we do codominance. And so, in those, you don't get red and white, but you also get pink. Because one tries to overcome the other and doesn't quite get there. Oops. I mean pink. So pink, red, and white. And so at that point, your genotype and your phenotype often look the same. I guess we didn't do that. The genotypic ratio would then be what? I guess we stopped there. What's the genotypic ratio? For somebody who was here. Yeah. 1 to 2 to 1. And if I say genotypic ratio, what are these numbers referring to?
Capital R, lowercase r. Or wait, no. Capital R, lowercase r, and the lowercase r.
Yeah. And what would the phenotypic ratio be? Yeah, again.
1 to 2 to 1. But with red, pink,
Red,
white.
pink. And so when you get incomplete dominance, and we'll see when we get codominance, you actually get the same thing. And given our new terms, heterozygous and homozygous, literally just 5 minutes ago, I found this. They're heterozygotes. They've got the 2. Oh, they're cute. Yeah, they're little baby goats. Delicious. We did that. Like that is literally this example, and I don't know why I said it twice. So I'm going to skip it, and we're going to go straight to codominance. Maybe we'll go back to that page. Codominance is when both genes are equally expressed. They are codominant. The genotypes of the parents in this case, we have red, and so what should we use for white? Lowercase r, but you see it, it's not recessive. So we should use capital R, except that would be very confusing, so I think some of you said, what should we use? W. So you get a different letter, and you keep it capitalized to show that you also, they're both dominant. There's no one that's greater or less than the other. And then I should have done that, that's split in white, so I'll do it in black, because you can't write on white on a white board. And then that way I can do this. And then you get red and white flower. So this is a red and white flower. Not a pink flower, not a white flower, not a red flower, red and white. Yes?
If the white was recessive before, why, could you have like a little w?
If the white was recessive, it would be a lowercase r. But we're going to possibly see a case in which we use other letters with regular dominance as well, but we'll do that afterwards. Okay. Codominance. All genes and alleles are shown in the traits. Where is my... And we use uppercase for both. So our parent cross, red times white goes to red and white. So as it says, as above, so below, that asks for the phenotypic ratio and the genotypic ratio. Please take the results of this. These are the, which generation? Parent P. This is the F1. Mate the children. And please get the F2. Put it together. Draw the flowers. Use your pencil crayons. And those of you who have been religiously carrying your pencil crayons ever since 4th grade when you were told you needed them and have never needed them in high school, this is your time to shine when you pull them out. For everyone else, you can just write the trait underneath red, white, or draw a little flower and use cross-hatching, shading, labeling. Regardless, put the trait in because I want to focus on the trait in the Punnett score in addition to the genes. I'll come around and check. Take a quick look. Put the traits in as well.
F2 generation.
So let's say it.
RW is F1.
Genotypic is also.
No, you're drawing two flowers, but it's actually just one flower. Yeah. But you're also just gave me the F1 cross. Parent in F1. I want the F2. Yeah, so that's completely different. So you have the F2. Yours is, you do have the F2. This is the F2. He had the F1. Yeah, you're doing fine.
What's the genotypic ratio is also
Excellent. Nice piece of shading.
Because in this case, the gene means
Look, it's
P.
not
The gene means
Yeah, but you're not leaving until 12:50.
Yeah.
What?
12:50.
Yeah, that's what he said.
No, I said 15.
But shh, you could have just totally
I thought it was joking. I did say 15.
Enjoy. Good luck. Are you playing a game?
Yeah.
Okay. Remember, you're only excused if you win. If you lose, I put it in as like an absence.
You're gonna lose. No, we're not.
What? Stop that. Positive
I don't
thinking.
know what you're talking about. You won like 8-0 last time. You lost. I don't know.
They won. If they won, if they lost the score, then they won in the friends they made along the way.
That's what I'm saying. That's the team spirit. What? Yeah.
Okay.
No, but these aren't always an F1, I mean an F2 cross wouldn't always be.
Oh, I was just wondering if it's that two cross, right?
Mhm.
So the F1 cross would be.
That's F1. So that produced the F1.
This is
You
an
take the F1, you make the F2.
But is there like this unsquare for an F1?
Yeah, you could.
Oh, okay, that's
Yeah.
right, yeah.
To make it for an F1, it's the reason we don't is because it's super easy. Because if you do this, the F1 would be this,
Yeah, they'd all be the same.
and then they'd all be the same. So we don't
That's why I was
have to.
confused on the page in front. Because we did.
So this, yeah, this was the F1,
Okay.
and then that was the F2.
Gotcha.
All good. Let's get someone to talk me through it. Class Dojo. B block.
This is my nostrils. Can I see my monster?
Yeah, can I see my monster?
No,
Why?
because it would take time. Isabel, what do I put in here?
That was the first monster to have.
Excellent. Fill in the boxes.
I was a monster when everyone else was
Ooh,
monsters.
I wasn't going to do the colors, but now you might as well continue.
You really said that.
So strange. Does that mean?
Gentlemen. Yes? Excellent. So now we have our, we can get our genotypic and phenotypic ratios. So, what would the phenotypic ratio be? Alexander.
1 to 2 to 1. Red, red to red and white to white.
And then the genotypic ratio, Jaden.
1, 2, 1. As R,
RR.
like, yeah. Wait,
Yeah, what?
Wouldn't it be like capital R?
It would be capital R, just seeing if you're paying attention.
RW and WW.
Excellent. And so for both of these, because codominance and incomplete dominance, you see the difference for the heterozygous. They will end up being the same. Also goes back to our unicorn. When I asked you for heterozygous recessive, that may not make sense in this context. But if you get something like this, well, you can have heterozygous dominant. And there are situations where you might get heterozygous recessive. So it didn't make sense here, but it might in the future. I have a practice sheet, and I just looked at it, and it was stupid. So I thought I would go to my old friend who knows everything. New one, keep going. Hello? Whoa. No, I don't want. No. No. There we go. Hello? I am sad, and the only thing that cheers me up is genetics problems.
So when it takes over,
With
it
Punnett
will spare us.
squares. Please give me a Punnett square problem. It can have regular Mendelian genetics, incomplete dominance, or codominance.
I think you need premium for this.
Thank you, Mr.
Yeah, you have to thank you.
Thank
That's
you.
Common.
Sincerely. Sincerely, Mr. No, I don't want to tell my name.
Oh, yeah.
Mr. Flintstone.
You have to say your name so it like
Flying
knows like
stuff.
to spare you when it like takes over.
Pardon?
You have to say your name so it knows to spare you when it takes over.
That's true.
Just, oh, it's true.
That's true. You're being so cordial right now.
But when you said
Say
just
not
to
Mr.
spare
Info.
you,
Say not
it
Mr.
it 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 just rhymed, and I'm sad. So, Mr. Despair.
You also
So
might
emo.
notify China that you're looking.
Something.
You're being too nice, bro. You need to work it.
Put up for us to
Yo.
protect it.
Go to Perplexity.
Nah, Copilot is better. Wait, you know DeepSeek? DeepSeek?
I haven't used it yet. I've heard of it.
Use go to Perplexity.
Oh, God.
To sign in for Perplexity.
Okay.
DT
All right,
is so
no.
better. It literally made it
There's
go back.
more than one way. Just can I catch?
Average view duration.
Mm.
15 minutes per.
As a Discord bot.
Ha!
Ask Snapchat AI.
I don't want it to know who I am. Use it.
Doesn't the school block it?
No, because I told them I use it. Here's my everything. Make it work.
Ooh.
And where? No, you can't do that. Missouri.
For my blog, for my arts
That's
blog,
why I
it's
can't.
good.
That's why
Yeah.
I can't pirate you.
I know blog.
No. You know what's the strat? If the browser
I
VPN,
scheduled
it works. But if it's like a if it's an application on your computer, it doesn't work because once the school gets on you get on the school Wi-Fi, it gives them
So-
administration.
We've never talked before. I would like an interesting and fun hybrid
Yo, he. Chat is
mono-hybrid cross question. It can use regular Mendelian dominance or codominance or incomplete dominance. It would cheer me up because I am sad without genetics problems. It is the only thing that gets me through the day.
Duh.
There.
No, sincerely not Mr. Neufeld.
Sincerely,
Yo. Not
Not-
Mr. Neufeld.
anyone you know.
You want me to put you on?
Okay, let's go.
Want me to put you on?
A certain species of fly. Good God, we just did this.
It's listening to you.
Okay, stupid head.
Yeah, you gotta work it.
That was dumber
Bro.
than a bag of rocks.
Put it to work.
It
Oh, I feel so
should
bad for
be
the ChatGPT.
interesting.
Yo, wait, why does it
And
evolve?
use
Why can you do
humans.
emojis now?
You didn't know it can use emojis?
I didn't know it was expressive like that. But I tried.
Oh, I highlighted the usage policies.
Yo, it's hurting its feelings.
What is
Wait, what? I thought
That's-
that was
Do a more
train.
creative. Ask them for a more creative one.
And more creative. More creative.
Period.
Explanation.
Both who can roll their tongue.
Or I will violate content policies again.
I thought you were supposed to say or I will violate.
It said D.
Blue eyes. The shift between redo is tricky.
Nah, I'm not.
See, that's just
Nah.
okay. Now this is just reaching. Like that's not harder. It's just weirder. Okay. Forget. Stupid.
Well, that's why you don't use ChatGPT.
You should use.
Use DeepSeek.
No, I came up with one in the other class, and I thought I could come up with a new one. I actually had to correct the one I came up with because it also was stupid, but it was closer to being less stupid than that one was. Where did it go? Where did it go? Where did it go?
That's why Nvidia is losing so much money.
Oh, hold it. This is us.
Well, because they can develop like AI like way better than like coding.
Should I short?
But I didn't
People
save
already
it.
shorting, bro. You're late.
I know, but
The code.
should I?
Better not
That
to
is
jump in at all.
disappointing.
Jumping in late. Yes. Really? Yes.
Didn't get saved. Do I have anything? I saved some of it. No, that's a prompt. I might be able to recreate it from memory. Let me try. Okay. There are two parents, both with brown eyes. They,
Are they true reading?
through the usual process, children.
Birds and bees, you know what I mean? Heck.
One with blue eyes.
You just call them Isaac?
One
Wait, oh yeah, my
with
bad.
brown eyes.
You know my name? Alexander.
And one with green eyes. Brown is dominant to blue.
Oh, so we're doing like reverse operation.
And green
We're doing it.
is recessive. Brown,
That's not. Oh, that's not. The
but
that looks like brown.
incompletely
She's reviewing film.
dominant
Tomorrow.
You're studying
to
the
blue. What
You're in
are the genotypes
this team is
of the using as many Punnett squares as it takes you. Now, this is an example. We've only ever had 2 letters, but you can have 3 because sometimes there's like people have different colored eyes. Green is now. If you were doing a problem, there's only blue, brown eyes and green eyes involved. You would have capital B for brown and lowercase b for green, because that'd be the recessive trait. However, we have a situation in which we have 3 different genes, so we're going to have to use at least 2 letters. So B is brown and lowercase b is blue, because that just makes sense with what the colors start with. And we'll make G green. It will still be lowercase, because it is recessive to brown. But it is co-dominant, not co-dominant, incompletely dominant with blue.
Wait, so but each parent can only have 2.
Each parent only has 2 genes. This is a monohybrid cross only. What are the likely genotypes of the parents? Go. I will ask some people for their
Oh,
ideas.
wait, this is like algebraic.
Yeah, you can do this.
It's low-key like algebra.
Yep. The other class solved it. So, what I want to tell you.
PG, like this. I like this.
Any ideas? You just start making Punnett squares if you don't know where to start with what the parents might be. That's helpful. But so like that.
So incompletely dominant means like teal eyes.
Ooh, interesting. Yes. Pardon?
Yeah, that's where they're pink, right?
Oh, I don't know. I'm going to ask people for what they think is correct. So, you need to explain the parents, and you need to be able to explain the children.
They both have brown.
Yeah. And you should be able to prove it with a Punnett square. Even if you can't solve it all the way, getting close, say, is good. I mean, close is only good in horseshoes and hand grenades, but it's still better than no.
So they both have brown. So they both must have one. Don't. So both green. Blue.
Does anybody here use DeepSeek?
Yeah.
Is it good?
It's good.
Or is it the same? Like, in what way is it? Could you tell it was better?
Well, the market says it's better.
Well, the market's freaking out not because it might be better. It might be better. Apparently, it was better at math. The market's freaking out because of how cheap it was to purportedly produce.
Yeah.
And then
Nvidia's code.
Well, if we can like download it to your computer.
maybe, yeah. And how they it won't be as good as the larger models. But what you do in a large model is that you get everybody else's work and you steal from them, and then you make your model. What they purportedly did is they took a model and trained it on a large model, so it learns the right responses,
Means if it's
but it has a smaller data set,
it'll be the one
so
that
it's
gets
much
matched.
smaller to be able to produce reasonable responses.
The one that
It won't do probably very well in hyper specified areas, but it'll probably be good enough if you're running a laptop. But I did see, OpenEye complaining, like they used our product to train their product.
it's like
You're complaining about copyright?
pink.
You?
Oh,
They trained theirs off of tons of work online that they did not have license to do. I don't think anybody's gonna feel sorry for them.
I'm thinking, calm down.
Like,
Well, if they
if
both have
one
B,
child
then
is
it's
green
gonna be
and
so
one
Mhm.
child is
Blue.
blue,
Yeah.
and one is brown, it means there
Mhm.
are 3 G's and
Yeah, there are. Yeah.
so there could be capital B, capital lowercase b, and lowercase g in like one thing.
No.
For
Yeah, you can only have two genes, one from your mom, one from your dad.
So how does it work?
Yeah, that's what I've asked you.
So one parent.
Get me your best explanation.
But it can't.
It has
No,
to be.
Eric.
That's
So
it.
one
explanation.
parent can have like
They
B,
can both have
capital B,
brown
right?
eyes
Basically, the one parent. Right?
without having a 75% chance of having a child with brown eyes.
No, that still doesn't make sense because to get green eyes, both parents need to have green eyes.
No, don't tell me why. Just write down your Punnett squares. Get it explained as best you
But it
can.
doesn't work.
It worked. The other, I will say this: the other class solved it.
I think
100% solved it.
He's brown.
Can the solution be that it doesn't work or it doesn't have to work?
Nope.
Wait.
Because
So if you had B,
both of them have
It
to have
and
can't
G.
work.
What if you?
The parents have brown eyes.
Yeah, so then
Yeah.
there's only that for the
Ariel, Dave.
Oh, I'm not going to give you any hints to potential answers.
Exactly.
That would be cheating.
How can one
No, I'm
child
not going to
have
check it. I'm going to ask
green
for
eyes and one
volunteers
blue if you need
Okay.
for their explanation.
Because it's co-dominant.
Ariel, you haven't been here for the past few
Bro, just say co-dominant.
But in codominant
No,
it's
it's
they
not
mix.
co-dominant. It's incomplete dominant. So one of them, one of the child it can be dominant, blue is dominant, and the other child is dominant.
Is it incomplete dominance for races? Like no, like pink or teal one type?
What if they both have BG? Look at B.
They both have a big because sometimes the blue is more dominant. But
Ooh,
That's creepy.
that's intense.
I don't think that's real.
Just going to steal that image. Oh, and I can't. Listen to me.
Yes.
What are you doing to me? Copy image. There we go. Paste. Okay. You cannot stop me from stealing things because this is my computer. Yeah. How do you like them apples?
I would be here.
I don't know.
It's just gotta be the extreme. One of them is like really blue and the other one's not as blue, but it's still blue.
Yeah, because it's incomplete dominant.
That's your fault.
Oh.
So
Second
Oh.
top
technically,
left.
he
Second
doesn't
top
actually.
Mm.
left. Second top left is your fault.
That, oh,
One's
I didn't see that.
bluer.
Baby.
So to get green eyes, you would need to have
Greenish bluish.
Oh my god. But then to get
And
That's those are black.
cute little baby.
okay.
Babies are so cute. And they smell so good. It's like crack. You ever smell a baby like at the top of their head when they got?
No.
Oh,
Yeah.
I need more babies.
Oh.
Yo, that's on the live stream.
So the
Yeah.
From that makes it like
so this one will have blue eyes.
I need.
This one will have green eyes.
They're not parents.
I'm gonna say the blue is
Adults.
wait no. The greens of the blue
Okay, that's just
is
ill.
so blue that
Um,
showing through.
That is AI generated.
yeah.
So this is
Uh,
this is
old.
Wait till both
Because
parents
they don't
have
look
brown
tired
eyes.
enough.
But I feel like
why is it finding like cancel?
Brown eyed dad.
you can't have a GG or a PB.
Oh,
That's impossible.
oh.
Especially if both parents know.
Oh, the Sigma.
What the
I don't know who that is, but even I'm falling in love.
Eyes are not brown.
Wait,
You have a wife.
Yeah, those are.
You have a wife.
Right, so we have room for a husband.
Oh.
What was that looking at the top?
Maybe
What
talk
was
to her
that
about
looking
it.
at the top?
Actually, I think she's mentioned that would be okay.
Yeah.
Really?
But then
Yeah.
but then they might have a recessive
Is that
gene
called
that
like a
just didn't show,
throuple?
It's
that
like
might show up.
two
in-
times love.
Whoa, that's AI. Okay, that one, I think that one might be real.
No, that's
There we go.
No, that's real.
Yeah.
That's it.
What is all natural hot mom?
Yo, it's body blue. Yo,
That's
Mr.
so
Lee,
wrong.
Mr. Lee, you should use like the bottom left photo, the one.
Yo, is that
That one?
She's
that
all
Wow.
natural hot moms.
I like that
All
one.
natural hot moms.
No. Go that one.
Why are you laughing?
No, no.
Oh, she had one blue eye. You're wrong.
No, it's like, I really have a connection.
Sexy, my confined space? No thanks.
Really big.
Hold it. Is safe search strict, please? Thank you.
She's still there.
Still
Oh,
there.
she's still
I
there.
don't know.
What is?
Okay, makeup for older women. Let's do that.
What?
That looks like a
What?
model.
What? What'd you say, Alexander?
Do you
Could
disagree?
you repeat that?
Do you disagree?
No, I don't even know what you're talking about.
Why is body blue there?
Okay.
If he goes back
Ain't
up.
no way.
Those are the parents. Those are the children to inspire you.
None of them are adopted.
You are to come up with. You keep telling me explanations wanting me to confirm them. Come up with your Punnett squares.
Ariel, fuck it.
Let's go. Okay. How many of you are done? Got something? How many don't
Where's
got
my
something?
sheet go?
Wait, if you have
Okay,
blue,
I'm gonna.
Wait, if you have blue and green eyes,
Does anybody think they solved it?
then you can have. Wait, if you
No, I
have blue and
think-
green
Does anybody think they've explained most of them? Okay. Who thinks they've made most of them?
Most of the squares?
No, like explained most of the children and parents.
Oh yeah.
Take these children away. I mean, children should be seen but not heard. Yeah. Okay. Volunteer. Yes, go.
Oh, so if both parents have brown eyes, so they at least have
No, I want the Punnett square. So what are you giving me?
one B each, one capital B for each
Okay.
person. And then maybe like one parent has a G and one has a lowercase b.
Like this. So if we pop it through, we get that, and we get that, and we get that. Oh, if you got two that are equal, like they're both capital or both lowercase, what order do you put them in? Alphabetical. You just have to have a way to do it, so that's what they picked. Okay, what color are these eyes? Brown. What are those? Brown. What are those? Brown. What is that?
Blue-green.
Is that green?
Bluish. Green.
What's blue? Come on, it's a house color. What's blue green? This is teal. So, did we explain? I'm gonna do this in pink. Did we explain the parents? Yeah, they're
Yeah.
both brown eyes. Parents are explained. Did we explain the blue-eyed child? No. Did we explain the green-eyed child? No. Did we explain the brown-eyed child? Yeah. You explained 1 out of 3 children. Yes.
Are they adopted?
Oh.
If you say they're
The only
all
ones-
adopted, you have, yeah, it could be. But if they're all adopted, that's the easiest way.
2 of them are adopted.
2 of them. So what's your square? You've only explained so far. You've only explained 1.
Yeah, exactly. That
So
was the
what's
only-
another Punnett square that we can use to explain more than 1?
Wait, what if?
Sorry?
B-
Did you just say BB and BB?
That's so cool.
So you will have to work out that a little bit. So what kind of B's?
Uppercase B.
So upper, lower, upper, lower.
No, the green child's
Okay,
adopted.
but they can't have all of them.
What?
But you're not getting green in this. So we're just green ones is
The blue and green make brown.
No, the green one is a mutation.
Does blue and blue make green?
Then we get blue. So that's sauce too.
Wait, this
Okay.
blue make brown.
So we'll make this one.
You say
We'll make this one light blue. Does it explain the parents? Yeah, so that explains both parents. They both have brown eyes. Does it
Science.
explain the blue-eyed child?
Yeah.
Yeah, we got a blue in there. Does it explain the brown-eyed child? Yeah, it's 75% chance they're going to have a brown-eyed child. Does it explain the green-eyed child? No. Does anybody have one that could explain a green-eyed child?
Yeah.
What's the green-eyed child?
Capital B G, or like yeah, one is B G and the other is also B G.
Oh, so you're going to do this.
Yeah.
So we would get.
It doesn't. It's the green one.
So this one. Do you explain the parents? Yes.
These parents can be teal, but secret.
And do you explain the blue-eyed child?
No.
No. Do we explain the green-eyed child?
Yeah.
Yes, because we got that one there. Do we explain the brown-eyed child?
Yes.
Yes. Okay.
Wow.
Yes.
Do they have 3 traits each? Like,
No. You get one from your mom, one for your dad. It's monohybrid Crohn's.
No, but
One's a
like,
mutant.
is it cool? Yeah.
One's a mutant. So that is actually a good explanation.
Yeah.
Yeah. So you could say
The green one's a
mutation. That is a new explanation the other class did not come up with. So that would solve, because then you could say that child has a mutation where its blue is not expressed properly and it is coming out green, depending on which one you want to. It would help if they could just keep having more children, and we could do like a statistical sampling, so like 100, 200 children or something. We can start looking at the amounts. That would probably make things a little easier. Yes.
Are these triplets? Because if they're not triplets, they might have been born in different hospitals and the lining might have been
Ooh.
It isn't even science anymore.
Hospital mix-up.
oh, like switching babies.
Switching babies. Yeah, one of them might not be related to them. I think in the parents, covers all of them. But anyway, we have a Punnett square, but there's one obvious explanation. Adopted. You could just say one adopted. That way, you're not trying to get away with all of them. Yep, one of them could be adopted.
One of the parents has teal eyes but has brown contact lenses.
One of them has,
Teal eyes but brown contact lenses.
but they're wearing. No, these are their actual eye colors. Now we're getting into like I've deliberately lied to you in the question. Yeah. Yeah. Yes. One of them. Okay. It might not be cheating. Because maybe they have an open relationship. Maybe one's a pre-existing child. However,
maybe they have another.
do you want to use this one or this one as for two of the children?
Keep the blue eyes one.
So let's keep. Okay, we're gonna go with this one. If we keep this one, we're gonna take one of the parents because you have to keep the parent then. And we've explained the blue.
Do they mate with their child?
Do they mate with their? Oh my God! No. I would like to point out, despite the amount of incest that has gone on, it is wrong at all
Oh wait,
times.
that doesn't work. Because how do you get green?
How do you get green? What kind of what could we put up here?
But then you get T. Oh, wait.
Yeah, that doesn't work.
But
Then you get teal. Don't you?
doesn't that mean
The parents is green.
the parent is
It would
one
have to
that
be
has
You kind of make the children.
So this only gives you brown-eyed and teal. So even if one of the parents cheated, does that explain it? No. So even with genetics, you can now go, actually, that's ruled out. That can't happen if that is true of the parents. So it just kind of doesn't work out that way, because if we assume that that's what each parent was in order to get either one, then you can't have that. So actually, you can actually say with some authority that this seems to be like it. Now, real world back to, is eye color controlled by one gene? No. So those of you that were saying, like, can't they have more than one gene? The answer is yes. You can actually get states that are like this. And you have to do dihybrid crosses, which we haven't done. So it does not correspond to simple Mendelian genetics. So please, if you have green eyes and then you've looked at all your parents and siblings, don't run back and say, our family's impossible. No, because I made a simple example that's not quite true to life. In addition, you've at least heard of people that have like one blue eye and one green eye. Because heterochromia. Because I've said, oh, these are incompletely dominant. Yes, they often mix. But how much each dye comes out is often controlled by the environment. And so that's why you can have different shades of green. Sometimes the blue is expressed a little more. Sometimes the green is expressed a little more and you get a shading. But sometimes, for whatever reason, one eye just has a lot of blue and very little green, and the other eye just gets a lot of green, a lot of blue. Same genes, but different expression, and then you get one blue and one green. You get something that looks a lot like co-dominance rather than incomplete dominance. And so I also made this more difficult by not incorporating some real world things that could happen. So if we limited ourselves to what I told you, then you could say, yes, this is it. But I don't want you to run away and then accuse your parents of anything, because the real world is a little bit more complicated. But there are a lot of things that do correspond to straight Mendelian genetics. Blood typing is one of them. Yes, there and
So
then there.
my one could work.
Your one could work, yes.
Wait, so what was
Yeah.
the other class?
Yeah, I was about to say, so that means like both the green and the blue eye child is BG, but what do you call it? In one of them, the blue is more pronounced, and in the other one, green is more pronounced.
And it could be the other class. Also said maybe the person who wrote this down, like they weren't lying. We're lying, Mr. Newfeld's example, but they don't know what teal is, so they just said green. And if we look at realistic pictures of green, the green I have, I think here, is a very extreme green. A ton of green eyes actually look more teal, or have like a greeny brown, light brown, and so they're not like startling green. I knew someone in high school who had heterochromia. She had one blue eye, one green eye, and I actually couldn't stare her in the face at all. I had to do a group project with her. It was awkward for like 2 weeks, because if I looked at her, she had like a green eye, one of them. It was so bright green, it like glowed, and then she would move it, and I'd be like, and because it doesn't match the other eye, and you're not used to it, I thought it was really, really weird. It wasn't that weird. I just thought it was weird, because I wasn't used to it. Okay. So now we've added in a little bit more complexity. Next day we're going to do dihybrid crosses. But also next day you have a quiz on protein synthesis and transcription and translation. So you can bring this worksheet with you. I will post answers tonight. For this, you are just to write out the process. So you can bring this with you. It can be with you while you do the quiz. I'll post the answers. So if you haven't done that yet, that would be a good thing to do. And we still have a few minutes left.
We can have early lunch.
You do get early lunch at 1 o'clock. That's already early lunch.
Like 12:55.
When I first started teaching here, I had to walk uphill both ways between Privet and this building. It was horrendously hard.
Are you going? Yeah.
Oh dear, crashed it.
Go get some shower.
And let's go back to ChatGPT.
I love shawarma. You want the soup one? Yeah. I did enough shawarma that I can be like genetically.
Give a parenting problem involving a dihybrid cross. Don't give answer only traits.
You get it? Yeah, bro. You need it, bro. I'm trying to save this guy. If you get a buzz, then like maybe 5 others get his buzz. No, it's not about that. buzz so your hair can be healthy. You had a buzz? My also had a buzz. It's pretty bad. Bro, you got like a bit of heat, bro. Like your hair is thinning, Tyler.
No.
Tyler.
that thin hair, bro.
No, but like, but like, look at it.
No,
You know what I'm
don't.
talking about, right?
No, we saw that.
It's not just thin. It's like, yeah, it's so. Maybe you need to oil it. Yeah, you need to oil up, bro. Bro, I need a buzz anyway. I'm quickly on one for it's over. Yo, can I do it? No. What if I find a sucker? What if I find a
Okay.
an 8
At this point, you haven't done a dihybrid cross, but I would like you, I don't think you have time to solve it, but you might have time to set it up. See if you can figure out what a dihybrid cross incorporating two traits would look like. What would the gametes be on either side from these parents? We've also given you mom and dad. They should have some combination in there, should be impossible. I did ask, when I asked ChatGPT before, it said only one was impossible, and it turned out all of them were impossible. And then it gave me another example in which all of them were possible, and it said that one of them was impossible. So it doesn't always know, but I think, hold it. This is the dumbest example I just realized.
Why?
Without even doing the cross.
They're all the same.
Yeah, what are all the children going to be?
They're all going to be
Straight hair, brown eyes.
Straight hair, brown eyes. Dad has both dominant traits. This is a misogynistic ChatGPT.
He's so dumb.
Dad is all dominant. Mom is all recessive.
Make the mom dominant.
So let's spice it up a little.
But
He's
he's
so
so
dad bomb.
Dad.
He's so dumb.
Okay,
He's so
let's
dumb.
not. Ahem. No. Let's do that and that.
No, dumb.
So blue eyes are
That's what I know.
I'm still trying to. Yeah, you're lost.
Yeah, that'll introduce some complexity in there. Okay, see if you can set up what a dihybrid square looks like.
so blue eyes are so blue and dominant.
Straight hair is dominant. Oh yeah, Dad doesn't have brown eyes. Dad now has blue.
And mom has brown.
Is it possible for your traits to like change? Because my dad used to have straight blonde hair and now it's black and curly.
Oh yeah, as you get older, your hair tends to darken over time. When I was a child, up until my early teens, I had white blonde hair, and I clearly, I don't even know if you can tell, I shaved most of it off. But I've noticed as I've gotten much older, it's starting to go white blonde again.
I don't think it's
Yeah.
I don't
Yeah, it's going white blonde again.
maybe without the blonde.
I can see it.
White
Damn.
blonde,
Damn.
white blonde, emphasize on white blonde. And you can also find, also as well, if you undergo or you know someone who undergoes chemotherapy, chemotherapy will often cause your hair to grow back curly.
You can do the same with
So there's a ton of environmental factors that can change things as well.
get the same.
We're going to just focus on the genetics. Okay, let me see your dihybrid cross. Okay. Oh, don't make it three-dimensional. You can represent it on a two-dimensional page.
Read them.
All you do is that.
I think I did it.
I'm just.
I don't understand it now.
You're on the right track, but what you have at the top is wrong. And what I said, you're on the right track. You wouldn't have 4 letters in it.
Then you could
would
have
but,
possibly 6.
but before, remember, we would
6.
start with 2 letters. And you
6,
put 1 in each box. Now you start with 4 letters, and you put.
What?
And then you end up with four in default.
Yes, yes. You will have more letters in the deck, but you're on the right track for size. You're on the right track, however,
Lowercase c.
you need a bigger box. You need more combinations.
So one of those, right?
The mix, the top is the right size, the bottom has better genes. So a mix of those.
No, but,
Wait, Mr.
no,
Wu.
but when you have Mr. Rico,
Mm-hmm.
when you have S, well, this is probably SS and D, like that's big S. And then there's a small S. Like S, big S, small S. and you go-
Oh, I see. Yes, in terms of combinations, you might be right, but I want you to show every possible thing. So that big S with that little b, that big S with the other little b, separate box. Don't summarize it, because you might get the percentages wrong if you summarize it
Did
like
you check the com-
that. Right size, but these need more in it.
How do you know that's right? What do you mean?
There's only one gene in each one. They're inheriting 2 traits, not 1 trait. And that's a lot of BS. Where's yours? That is not a Punnett square.
Tell me why
You didn't
mine.
even try to make Punnett
I
square.
don't understand.
Tell me why mine.
That is, you only have one. You only have 2 genes in each one,
Wait.
but we're considering 4 genes in each parent, 2 traits. So you need to have 2 traits, 4 genes in each of the product boxes.
Wait, Mr.
I don't know
So
where
would
to
it be
put
like?
them.
Wait, yeah, I understand
Well-
it now. I understand it now.
When you did a Punnett square,
Down the black guy,
Four.
but
and let's say we do dad,
It's like a 60.
what would go in each one?
Yeah, actually, you did one. I did, bro. I was not like that.
Yeah. So we would divide it up there, right?
Oh wait, so should I make another row?
So yeah, you need more.
Wait,
Mr. Dude, did you check mine?
Well, given the bell's gonna go in 30 seconds, I will do this. I will just show. I will. If I took dad,
That's what I did the first time.
yeah, but people put it in individual. It divides in half. So
Oh, it's like.
this one goes with that one.
Oh.
This one goes with that one. That one goes with this one. And that one goes with that one. And you do the same for mom, and then you combine them all.
Oh, at that point, it's like.
Before the boxes were 25% each, what would they be in this one?
They would be 100 divided by 17.5. No,
You're really close.
It'd be sub 9. It'd be sub 10.
It'd be what?
Wouldn't it be 100 divided by 16?
Yeah.
Yeah, so it'd be sub 10.
Yo, it's lunchtime.
Woohoo!
Oh my god, that day went by so fast.
Alex,
Mm-hmm.
can I not go to sport today?
Yes.
I had a really sore throat, and this morning I had like the
Why would
sweats.
I?
Or,
You had a what?
like the sweats, like
Oh, okay.